Hello everybody, and today we will be covering our second tutorial, which will be Newton's third law. So when you've heard about Newton's third law, you may have heard the phrase chucked around, each and every action has an equal and opposite reaction. Well, while that is technically true, it's not quite what Newton said. So what Newton said, I'm not going to write it up here because the handwriting is terrible with the paint tool, like just about everyone else, is that if object A exerts force on object B will apply opposite force along the same lines of action but in the opposite direction. So, for example, we have the floor, right? And say, for example, we've got a box of CDs that weighs, say, 2 kilograms. So, because it is 2 kilograms, it will exert a force of 2g newtons, which is around about 19.62 or something, because 9.81 times 2. Under Newton's third law, in order to maintain the equilibrium of the thing not moving, it means that object B, i.e. the ground, must exert on object A the exact same force in the exact same direction, but like this, so long as B remains like non-snapped. So we call it R, but R would equal 2g newtons. That's basically Third's law. We can do some interesting examples with this. So take, for example, we've got a box of, I don't know, something. Maybe history books or something. Say that weighs 5 kilograms. I'm going to bother just doing that, so 5g newtons. We have R up here. So R will equal 5g newtons. It's basically just a rerun of the other one, but this is where it gets interesting. So this rule doesn't just apply to the weight. So if we have, it gets very interesting once I've covered resolving verticals and horizontals of different forces. But say we've got a weight. Let's say we've got a box of I don't know, maybe a laptop or something. Say it weighs 2.5. So 2.5 g newtons, and for some reason you've gotten pissed off and thrown it at the ground. Like, I don't know, maybe the thing stopped working or something, and you throw it at the ground with something like from this part here, so like you sort of flipped it around somehow, like some ninja stuff or something, like you just ninja threw it at the ground with maybe, say, let's say you've got muscular dystrophy and throw it at the ground at 30 newtons. Now under Third's law, it doesn't just count 5g, the 2.5g newtons. What R would be 2.5g newtons. Probably put an R there, probably. Plus 30 newtons. So in order to get R, we add these together. So R equals, what's 2.5 times 9.81? I'm not going to get our calculator for this, so it's about 19.62 plus, say, 4.5 to represent, so that would be about half of 9.81. So plus maybe 0.405, 05, yeah, so like that, because 0.81 over 2 is that, plus 30. So in order to get this, we do 19.62 plus 4.5. I've probably gotten this wrong because I'm not using a calculator, but I think you can forgive me for that. It's difficult. So we've got a 5 here, 2 here, 6 plus 5, 11, 15. So we're going to do a 5 here, 0.1, so 9 plus 4, 20, 13, so that's 14, that's 24.25, so let me just check that with a calculator, because, you know, just going to, whenever it starts to respond, thank you, just going to check that on my calculator. You know, in hindsight, considering how short this episode I think is going to be, maybe I should have done it in the other episode as well. But, oh well, can't change it now. It wouldn't flow. Plus 0.405. Yeah, I got that right. But then I'm just going to do 2.5 times 9.01. Make sure I didn't get that right. Yeah, I got it right. So, 24.525 plus 30. I think you can probably do that in your head. 54.525. So R equals that. 525. I could probably make this more complex, but then again I've got resolving verticals and horizontals planned for a later tutorial, and that's when things get quite interesting because you have to resolve forces with trigonometry and things like that. So this is obviously our second tutorial on Newton's third law. Thanks for watching, and in the next episode we'll be covering scalars, vectors, and scientific notation, otherwise known as standard form. Thank you for watching, and I'll see you later.